Hello, welcome to Maths with EJD. In this video, I'll be taking another structured problem in, well, it's one part more or less, but the one part is divided into three. Here we're dealing with a data that pertain to the number of, the following data rather, which pertains to the number of years which 10 applicants for a foreign job studied French in high school or college and the grades they received in a proficiency test. So we have number of years and grade in test. So someone who studied for 3 years got 72. Someone who studied for 2 years got 45. Someone who studied for 4 years got 70. Someone who studied for 5 years got 81. Someone who studied for 3 years got 54. Four got 75. Four got 69. Two got 55. Five got 86. And three got 60. And there are 10 of them. Let's be sure that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So we have to determine the least squares equation which will enable one predict y in terms of x, and then B, fit a line of best fit to the scatter diagram of the data. C, use the equation of the least squares obtained to predict the grade of someone who has studied French in high school or college for 4 years. So we want to predict the grade. So we can take the number of years as x and grade in test as y. So let's go for that. Okay, let's so we say let's number of years. Okay, before we even do that, right? Um, okay, before we do that, let's just answer question A. To me, question A looks like, going straight, just stating the equation that is required to do that. Then question B is actually where we get the actual line of best fit. Right, so let's have that. So determine the least squares equation, which will enable one predict y in terms of x. So I can say the least squares equation, which will enable one predict y in terms of x is given as y equals beta naught plus beta 1x plus epsilon. Now, here we need to know that y is the dependent variable. Y is the dependent variable. In our case, that should be the grade. So dependent variable, we can take that to be the grade. And then we have x to be the independent variable, which is the independent variable. So that we can take to be the year of study, right? We take that to be the number of years, okay? So we are considering the case where the number of years seems to determine the grade someone gets in the French test. Of course, beta naught now is the intercept as the intercept. That's the intercept. So that's more like the base, that's the base, that's the base grade someone gets. Okay. So if you're not considering number of years at all, so if someone has not even studied at all, so the person is considered to get that basic grade, and that's the intercept. And then we have the slope. That's the slope. So the slope here actually represents the rate at which the rate at which rate rate at which grade increases rate at which grade increases for an additional year. So for every additional year someone studies, this is the rate at which the grade increases. Okay, that's the slope right there. So let's go for this. So for me, I feel this answers question A actually. So question B now, I want to fit a line of best fit to the scatter diagram of the data. Okay, B now, B to fit a line of best fit to the scatter diagram of the data. So that means at first we need like a scatter diagram. And a scatter diagram is really simple. So since you have identified what our X should be and what our Y should be, um, okay, or better still, so we already know. Okay, before I even do that, let's state clearly what our X is. So let X be the independent variable. Let X be equal to the number of years, right? Number of years, number of years, and Y is the Y is the grade in tests. Y is the grade in tests. Okay, so we have the number of years on the x-axis and the grade in test on the y-axis. So we have number of years, that is x here, that's years. And then on the y-axis, we have grade, the grade obtained. So the number in years, the highest is 5. And for the grade, the highest is 81. Okay, so we can just do it in terms of okay, we can use that kind of scaling. So we can go in fives probably. Let's see if that works. Or we can go in tens. So this is 1, 2, 3, 4, and 5. And up here, we can have 10, 20, 30, 40, 50, 60, 70, 80, and then 90. You can go that far. Then scatter diagram simply means just plot the points against themselves. Somebody who studied for 3 years got 72. So here you have 3 against 72. So 72, so 3 is like this. And 72 is somewhere around here. Okay. Then you have the next one. You have 372. The next you have is 245. So 2 years scores 45. So 2 against 45, somewhere around here. Okay. Then the next one, that may not be perfect because I'm not using a particular a special graph. So if you should probably consider using a graph for this if possible. Then 4 against 70. 4 years scores 70. 4 years scores 70. So this is 4 against 70 right here. 4 against 70. Okay. Then we have 5 against 81. 5 against 81. So that's 5. 81 is somewhere around here, and 5 is down there. So 5 against 81. And the next thing is the 3 against 54. 3 against 5, 4. So 54 is somewhere around here. And that goes for 3. 3 against 54. Then we have 4 against 75. Then 4 against 69. 4 against 75. So we have 4 against 75. Let's say 75 is somewhere around here. And then 4 against 69. 69 is somewhere around here. Okay. So then we also have 2 against 55. 2 against 55. 2 against 55. 55 is somewhere around here. Then what else? 5 against 86. 5 against 86. 5 against 86. Something like this. Okay. 5 against 86. And we have 3 against 60. 3 against 60. This is 60. This is 3. So that's the scatter diagram. So the next thing we need like a line of best fit. We need a line of best fit. That's what the question is. So fit a line of best fit to the scatter diagram of the data. So I said to fit a line of best fit to the scatter diagram of the data. So we say let X be the number of years, and y is the grading test. And that's why we have this graph. So this is the scatter diagram. It's called scatter diagram because you just have the points all over the place, and that's it. So to obtain the line of best fits, I already said it before that we have y equals beta naught plus beta 1x. And here we need to find, so we need this beta 1 now. Beta 1 is simply n summation xy, okay, minus summation x summation y divided by n summation x squared minus summation x all squared. And once we get that, we also need beta naught. Beta naught now is y bar minus beta 1 x bar. And then if we need to predict something, so to predict a value, we have y bar, y cap is the predicted value. Now equals beta naught plus beta 1x, which we would have obtained above. So let's start by looking for beta 1. So let's start. We can say that to find beta 1, so we need the data now. We need the data, the original data given. We need it for this. So let's go for that now. Okay. We have X and Y, right? X 372. So X is 3, Y is 72. That's the first point we have right there. Then we have the next one, which is 245. 245. 245. And next we have 245, right? The next one would be I'm trying to get everything in one place so I don't have to keep going back and forth. Okay, so we have 372, 245, then 470, we have 581, we have 354, we have 475, 469, we have 255, we have 586, and lastly 360. Okay, you want to double check to be very sure everything is in order. Okay, so 372, 245, 581, and so on. I think it's fine, right? I think it's okay. So 372, 245, 470, 581, 354, 475, 469, 255, 586, and 360. Okay. So we have this now. So based on the equation for beta 1, right, we need the summation of x, we need the summation of y, which you can easily get by summing up this. In fact, let's do that right now. But then hold your calculator very close so you don't get into trouble. So you have summation x now is equal to, let's see that. So this is 3 plus 2 plus 4 plus 5 plus 3 plus 4 plus 4 plus 2 plus 5 plus 3. You have to be careful. You have to double check, in fact. Okay, again, we have 3 plus 2 plus 4 plus 5 plus 32453. 32453. Okay. 32453. Then 44253. 32453 plus and 44253. Everything is 35. That's 35. And we need summation of y. I mean summation of y also. So for summation of y, we have bigger numbers. So let's be careful now. 72 plus 45 plus 70 plus 81 plus 54 plus 75 plus 69 plus 55 plus 86 plus 60. So let's check again. 72 plus 45 plus 70 plus 81 plus 54 plus 75. 72, 45, 70, 81, 54, 75, 69, 55, 86, and 60. So the total of that is 667. Okay. So what are the other things we need? We need summation x squared and we need summation xy. So those two are the other things we need. So let's go x squared and xy. So let's do x squared now. X squared and xy. So this bear a bit of resemblance with Pearson correlation coefficient, except that we don't have to worry about y at the denominator here. So we need x squared and we need xy. So 3 squared clearly is 9. 2 squared is 4. 4 squared is 16. 5 squared is 25. 3 squared is 9. 4 squared is 16. 4 squared is 16. This is 4. 2 squared as this. 5 squared is 25. 3 squared is 9 again. So let's check. 9, 4, 16, 25, 9, 16, 16, 4, 25, and 9. So let's sum that up again. So that will be 9 plus 4 plus 16 plus 25 plus 9 again plus 16 in 2 places plus 16 plus 16 plus 4 plus 25 plus 9. Okay, let's check. 9, 4, 16, 25, 9, 16, 16, 4, 25, 9. And that is 133. So summation x squared is 133, like that. And then we need summation xy. So carefully, 3 times 72 is 216. 216. Okay. Then 3 times 72 is 216. 2 times 45 is 90, I believe. 4 times 70 is 280. 5 times 81 is 405. 3 times 54, let me be sure. 3 times 54 is 162. 162. 4 times 75 is 300. Yep. 4 times 69. 4 times 69 is 276. 276. Then 2 times 55 is 110. 5 times 86 is 860 divided by 2. That's 430. Okay. 3 times 60 is 180. So that the summation of xy will be equal to. So now let's be careful with that again. Okay, let's check. 3 times 72. 7 times 2, 6, 21. Good. 90, 280, 5, 4, 8, 405. 3 times 4, 12. Remain 1, 162. 4 times 7, 4, that's 20. Have 2, 28, 30. Good. 69. 4 times 69. 4 times 70 is 280. So remove 4. That's 276, correct. 2 times 55 is 1. 5 times 86 is 86 times 10, that's 860 divided by 2, 430. 3 times 60 is 180. Good. So we can sum up all of this. So this is 216 plus 90 plus 280 plus 405 plus 162 plus 300 plus 276 plus 110 plus 430 plus 180. Okay, let's check that again. 216, 90, 280, 405, 162, 300, 276, 110, 430 plus 180. And all of that is giving us 2449, 2449. So I think we have everything we need now. Yep, we have everything we need. So we can go ahead and say, therefore, beta 1 is equal to, I just want to repeat that, summation x, y minus summation, no, n summation x, y rather, then summation x, summation y divided by n summation x squared minus summation x all squared. That's what the formula says. So we can put all the values we have now. So beta 1 is equal to n. Okay, n is the number of the pair of points. N is equal to, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10. So n is 10. So we have 10 times summation xy. Summation xy is 2449. 2449. Okay, minus summation x. Summation x is 35. Summation y is 667. That's 35 times 667 divided by 10 again into summation x squared. Summation x squared is 133. 133 minus summation x again, which is 35 all squared. Okay. Summation x all squared. That's what the formula says. Okay, so we can tidy things up now. So we have beta 1 equals 24490 minus 35 times 667. 35 times 667. That is 23345 divided by 1330 minus 35 squared. 35 times 35. That is 1225. 1225. Okay. So that beta 1 is equal to 24990. 24490 minus 23345. So that is 1145. 1145 divided by 1330 minus 1225. So that is 105. So that beta 1, okay, beta 1 is equal to 1145, 1145 divided by 105. That is 10, 10.9, 10.9, okay? That's just 10.9. So beta 1 is 10.9. That's the, what is it called now? That's the slope, okay? So that's beta 1. The next thing is to find beta naught, okay? So to find beta naught, we already said beta naught should be equal to, what's that now? Beta naught is this, as y bar minus beta 1 x bar. So beta, okay, that's y bar minus beta 1 x bar. So y bar is actually summation of y all over n. And summation of y, from the table, we should have that already. That's 667. That's 667 divided by 10. And the answer is that's 66.7 actually. 66.7. So that is y bar. Then x bar is summation of x all over n. And summation of x is 35. So that's 35 divided by 10. And that is 3.5. So that's easy peasy, like we say. So, and we, of course, we already know beta 1 to be 10.9. So we can say, therefore, beta naught is y bar 66.7 minus beta 1, 10.9. That's 10 10.9 times 3.5. Therefore, beta naught is equal to 66.7 minus 10.9 times 3.5. 10.9 times 3.5. That is 38.15. 38.15. So that beta naught would be 66.7 minus 38.15. 38.15. That's 28.55. Beta naught is 28.55. Okay. So we have everything we need. We have okay, no, that's not what we need here. We have beta naught. We have beta 1, right? Then we have beta naught. So beta naught obtained, beta 1 obtained. And with those two, we can get our equation. So what's the answer? The question itself, it says fit a line. It says to fit a line of best fit to the scatter diagram of the data. So we can now say, therefore, so we can say, okay, can say, therefore, the line of best fit is obtained as y equals beta naught plus beta 1x, and that is y equals beta naught is 28.55 plus beta 1 is 10.9x. So this is the line of best fit. It's the line of best fit. Okay. So with that equation, you can actually predict scores, based on the number of years studied. But then that's not the end of the question. We have a D part of the question which says to use the equation of the least squares obtained to predict the grade of someone who has studied French in high school or college for 4 years. So X is 4 years now. So, okay, well, before I even go to that, right, the line of best fit means that this equation, Y is 28.55 plus 10.9x, 28.55 plus 10.9x. The line of best fit means that I now come here and, you get a kind of line. And this line now is that Y equals 28.55 plus 10.9x. That's the idea of line of best fit. That's the line that best estimates, that fits the data better. Okay, that's the idea of line of best fit. Okay, so now we have X. So D to estimate uh grade, which is Y cap now, given that numbers of years, X is 4. Okay, so we just take our equation. We have Y equals 28.55, I believe. Yeah, 28.55 plus 10.9x. So Y now, okay, that's Y cap because you're predicting. That's 28.55 plus 10.9 times 4. So that is Y cap equals 28.55 plus 10.9. Okay, we should multiply that out. Plus 10.9 multiplied by 4 is equal to 43.6. This is 43.6. So that Y cap is equal to 28.55 plus 43.6. That is 72.15. Okay, so we can say therefore for someone who studied French for 4 years, the predicted grade in the test, would be 72.15. So based on that line that we fitted to. So that's the end of this question. It's been an interesting one again. So you want to practice, and get used to all these nuances. If you have not subscribed to this channel, you don't want to forget to subscribe. I mean, right now, and afterwards, don't forget to hit the notification bell so you can always get alerted each time a new video is released or each time I want to go live. Then don't forget to like and also comment. Comment. Let me know if you want me to teach a particular topic or treat a question. Then don't forget to share so that more people can have access to all this great learning. Till I come your way again, be the best always. Bye.